Hi everyone, today we will be going over the 2019 F equals MA Exam 8 Problem 1. The problem states that a coin of mass m is dropped straight down from the top of a very tall building as the coin approaches terminal speed, which is true of the net force on the ball. So the first thing we have to realize about this problem is that terminal velocity is when the net force on the coin is 0, right? So on the coin, there are two forces acting on it. The force of the air particles pushing up on it and the force of gravity pulling down on it. So we know after the coin reaches terminal velocity at this point here, the net force will be 0, right? And we can calculate net force by doing the force of the air particles minus the force of gravity, as if we take the force of the air particles in the upwards as positive direction, then the force of gravity is in the negative direction, downwards. So if the net force is equal to 0 after the coin reaches terminal velocity, then that should mean the net force should be less than mg, which is basically fg, before it reaches terminal velocity. Because the force of the air particles has not yet exceeded the force of gravity before it reaches terminal velocity. So looking at our options here, option A says the net force is upward, which is obviously false because the coin is moving downwards. The option B says the net force is 0. We also know that's false because the coin hasn't reached terminal velocity. It's approaching terminal velocity. Option C tells us the net force on the coin is downward with a magnitude less than mg. And that's true. The net force on the coin is downward as the coin is falling downward, and the magnitude is less than mg as it hasn't reached terminal velocity yet. So we choose C and we're done.